Okay. Starting up the stream now.
Hopefully it doesn't crash. I've never seen it crash. It's just.
I've never seen a crash either.
I thought I'd say it so it doesn't happen. That's how it works, right?
All right. Thanks for your patience, everybody. I wish we've done this enough times by now. I should have had it figured out, but I think we're good. We're streaming at the moment. So Will, if you want to take it away, I will get the slides for you while you go, and should be good.
Absolutely. Thank you, Sam. I'm Will Klein. I'm out of Longmont, Colorado, but this is React Denver, as in Denver, Colorado. Though we have guests from around the world. We have Seattle, we have Argentina, maybe some other places, and who knows who's going to watch this on the YouTube live stream or on the video later once it goes straight to YouTube. So advance the slide. Hope you all are doing well during this time. It is crazy, bonkers, and it is wonderful to connect with you all online. Whether it's anytime I jump on a call with one person or 20 people or however many, it's always a great pleasure just to reconnect with other people. And this is something that we're going to keep doing as long as we see any need for it to stay remote. And I can't remember exactly which months we took off. We took off a month here and there to make sure we're taking care of ourselves. We hope you'll do the same. Tune into whatever meetups you can, when you can, and stay safe out there. Tonight's sponsor is Zoom. I don't think we've spent any of their money yet. They sponsored us right before the quarantine happened. And it turns out they've been hooking us up with an awesome Zoom experience for our meetup. And it's been really, it's been really fun, as you can see, getting this meeting started. It really has been awesome. We're happy to have them in our corner, helping us out. They were super eager to jump in and support the community. And we also have support from Turing as our venue when we do get to meet in person, and Salt is helping us with our meetup dues. And as always, thank you to our Open Collective supporters. These are some of the individuals and organizers that have supported us on Open Collective. We do all of our finances in the open, so you can see where the money comes from and where it goes. We do not make any money on this. We usually don't expense everything, but we're very happy and grateful that we can expense all these little things that add up for putting on the meetup. I want to throw out real quick, this is an old snapshot of the collectors page. Raheem, thank you, because you're not only #1 here, but you've donated twice as much so far because you did a recurring membership or supporting sponsorship, and we really appreciate that, and that means a lot to us. So whatever you can do, whether it's for us or a conference or a meetup or any other cause, I think now is a great time to reach out and support who you can. If you're hiring, we'd love to hear from you. Please post on the meetup page. Post a link to your job, tell us what you're looking for, tell us why it's interesting, and how we can maybe ask you questions. The meetup page is the best way to do that right now. And announcements, we definitely have one tonight, but I want to ask anyone on the call if they have any announcements, any meetups going on in the next couple of weeks or conferences they want to share. Okay, then I will queue up Jim Liu. Back up one. I met Jim at Cascadia.js in Seattle last year, and I had a fantastic experience. And I asked him to join us tonight to tell us about Cascadia.js 2020, because it's a little bit different this year, but I'm still very excited. Jim?
Yeah, thanks, Will. And hello, React Denver. This is so great to see you all here virtually. We just had our first conference meetup last week and it was really awesome. And I couldn't believe that how I get to hang out with folks virtually in this environment. But let me tell you a little bit more about Cascadia.js. The event will be hosting online on September 1st and 2nd. And we have pretty amazing talk lined up for all of you. Hopefully, those are all the topics that you care about. Either it's the GraphQL or the latest serverless development, or how do you deploy your web app on the edge. And more importantly, Cascadia has always been a fun event that in addition to speaker lineups, we have breaks and fun activities to connect you with other conference attendees. The pro tip would be sign up before this Friday, because then you can get your conference WAC and the goodie box right before the conference started. And we made a discount code just for React Denver. So I'll post that in the meetup page, and please check us out.
Well, you're underselling it. So I went 2 years in a row, and I'm going this year. I was going when it was in person because I've had such a great time there. It's been a really wonderful community. It reminds me a lot about Colorado, just very welcoming, very encouraging, and a lot of fun. Two things I'll share. There's a number of there's like 2 speakers from Denver, from Colorado. And the Master of Ceremonies, I don't know if she's been formally announced on Twitter, but Cassidy Williams is going to be the MC, and she's got some of the funniest things on Twitter right now. So I am really excited for that. And they're doing a lot to make sure the talk's going to be great, but there's things like karaoke happening. And I also got to experience what the hallway track will be like at the pre-conference meetup that they had last week. It was a really cool experience. It was even easier to socialize in this virtual tool than it would be like at a live experience in many ways. So it promises to be like somewhere halfway between what we're used to for in-person conferences and things like this, which we don't get to like talk one-to-one very easily. So they're doing some cool things. So definitely check out Cascadia.js this year. All right, so any other announcements, or should we get on to talks? All right, let's get to talks. Who's next? All right, so we have MVVM with MobX, and this is an interesting topic for me. I have heard great things about MobX for a long time, but I've only spent maybe like 1 minute looking at their docs, and I just haven't had the chance to get into it. And MVVM is a term I have not heard for maybe 7 years. It's still very relevant, though. I just haven't heard it in a long time. So please give it up for Andrei Hetsevich. I hope I didn't butcher your name.
Almost. It's Hetsevich, but yes,
Hetsevich.
It is Andrei. Hello,
Awesome.
everyone.
Thank you,
Now I have to figure out how to share a screen. Here it is. Hey, host disabled attendee screen sharing.
Oh, that's my bad. Let's get that fixed here.
Unacceptable.
Yeah, I know, right? All right, give it a try now.
Okay, I wanted this one. Can you hear me fine?
Yeah, you sound great.
Okay. So my name is Andrei Hetsevich. I'm JavaScript developer, currently focused mostly on the front end. And today I'm going to talk about React, MobX, state management, and about the way how we can implement model view model architecture in React by using MobX. So MobX isn't the state management that is specific to React. It can be used with other frameworks as well as with vanilla JavaScript. And here is some numbers from npm.js that gives us understanding on how MobX popular in comparison with the most popular state management for React, Redux. So way less popular, as you can see. Often when we think of React and the usage of React with the state management, we think of 2 kind of major things, store and components that render values from our store. And MobX is the same way. And if we take a look at the MobX documentation, we will see there are 4 major things. And those things are state, computer values, actions, and reactions. 3 of them we see at the store side. And those are state, and those are observables value. Computed values, they are kind of observables too, but they're calculated based on the state. And actions are the methods or functions that change the state. Reactions is on component side, and in the case of React, those are the components. So they react to change of state or computed values, and they cause re-rendering. In MobX, in order for React components to react to change of observables, we have to wrap each component into this specific observer that comes from MobX React package. And to finalize the setup of MobX React, we might want to use the provider in case if we don't want to pass the store down through the tree of components. And MobX documentation encourages us to use React context API for that purpose. So this schema is basically the high-level overview of React MobX setup. And now let's move to some code examples I put together. And here is the first one. This micro app, just one component, some observable values here. Here on the left, we can see the code for this micro app, and it's basically one file, and it consists of 3 parts that in real world would be separate files, but for demonstration purpose, I combined everything in the one file. So it's store, its app entry point, which would be probably in real life or your app.js or app.ts. And here is the component that uses the store. In the store, we can see 3 things that I just mentioned. So in this diagram, state, computed values, and actions. We have our state, our observable value. We have computed getter, which is our observable value multiplied by 2, and each time value changes, doubled value is recalculated. And the action is a simple function that changes observable value. For some of us, this add observable, add computed, add action syntax might be new, and those things are decorators, and decorators in JavaScript or TypeScript are things that allow to bring in new functionality to your classes, to your class properties, to your class methods. And in this case, what it's bringing in is observability. In app entry point in app.js, we instantiate the store and we pass it down to context provider. And in the component, we get the store from use context hook. And at this point, we're good to render the values and use the actions. So one thing about actions, the rule is that whenever you change observable value, the method should be decorated with add action. And here in the component that renders values from the store, we can see observer, which I mentioned on the diagram as well. So it's pretty simple example, everything combined, as I said. And now let's take a look at something that is very simple as well, but just a little bit more involved. So in this mini app, we have 2 components. One on the right, it renders some values, one on the left. And on the left, we have buttons that change the values. So let's take a look how it's done in the code. And here we'll see the proper separation of code between files. So here we have a simple store, which contains 2 observables, 1 computed, which is the sum of observables, and 2 actions. One decrements the first observable by 5, and another one decrements the second observable by 5 as well. Again, in the entry point, we instantiate store, pass it down to context provider, and render left and right component here, right one. renders some values from the store, and the left one uses actions from the store as button handlers. So again, pretty simple thing, but this demonstrates the separation of the code between files. The following example is very, very similar to the previous one. But here in the left component, we have some addition. And this addition is those arrays of values, and you can call them historical stacks. So each time we generate value 1 or value 2 or sum is generated, we push it to the one of historical stack arrays, and at that point we render the left component. Before I dive into how it's implemented, let's do just a brief analysis of what data we're dealing with in this mini app. And in this app, we have some value, some data that is shared across the app. So basically between our components. And that data would be the values here, because we render them on the right, and we use them for rendering the arrays on the left. So this is basically the data that we potentially want to see in the store that is shared between components, and those are already there. The arrays, however, they're pretty local to the left part of the app, to the handlers component. So I don't see any big reasons to clutter store with them. So those I would rather define as just a regular React state with use state hook. Let's see how it's implemented in the code. And here in the code, the store is going to be the same one, no changes there. And the only change we'll see in the counter handler component, the left component. So, and as I mentioned, here are our 3 historical stack arrays, and handlers now are handlers for the buttons here are a little bit more involved, because besides calling the actions from the MobX store, we want to call setters that change the historical stack arrays. By looking at this example, you would say that, well, there is nothing new. There is nothing new from the perspective of MobX in this example, and you would be absolutely correct. So why did I include this example here? So before I answer this question, let's go a little quick to example 1. So I'm going to point out here one thing that is pretty basic and probably is very clear to the majority of us, but still. So here at app entry point, we instantiate the store. Then we pass it down to context provider, and then we get it from use context hook. But one thing to realize, one important thing to realize, is that the passing it through the context provider isn't changing the store anyhow. So it's not adding any observability, not adding any additional functionality, no nothing. So basically, the instance that we get here is the same one that we end up with here. So, and that makes me think that what can I do? Instead of passing the store down through the context provider, I probably could just instantiate the store right here and to use it that way. Well, clearly it's going to work in the exact same way. But if you think of this kind of implementation from the point of store, it doesn't make sense, because this one is going to be in real life a separate file. And basically what I did here is I defined the store that is local and accessible to a single component. And it doesn't really make sense to have the store that isn't shared. Well, but if we take a look at it at a slightly different angle, it really does make sense. So let's go back to example 4. So here, what if I try to create the MobX store that is local to this component? And I will try to convert those React state arrays into MobX observables. And I will try to convert the handlers here into MobX actions. And I'm not going to call this store a store. I'll call it a view model. And this is implemented in example 5. And you cannot see any changes in the browser because it's working the same. But there are quite noticeable changes in the code. So here is example 5, and on the left we have view implementation. On the right is the regular React implementation. So we took the regular state arrays, and now they're converted into observables. The handlers here on the right are now converted into actions on the left, and in the actions we change the observable arrays. And of course, here in the view model, we need access to the global MobX store for this app, because we execute actions from the MobX store here. And now if we take a look at the component itself, you see how it's very streamlined, it's stateless, and it's logicless, and all the values or handlers that we're using inside of JSX now come from the view model. The one thing to note here is this use instance hook. Really, the function component that we're dealing with here, each time it runs, each time we see the render of a value, the entire function runs. So we don't want to end up with a brand new instance of the view model each time we see a rendering. So, and this is exactly, and what use instance hook allows us to do is to instantiate view model only once, and then we reuse the same instance during the entire life cycle of the component. So another thing here to note about the MobX, that we can simply mutate arrays or objects. So MobX is mutable, and even though it's mutable, we see when we mutate, we see changes in the component, and this is one of the noticeable differences of MobX versus regular React state or Redux. So that's basically it regarding the main idea of this presentation, to see how view model can how we can separate logic from the view into the view model. But it's always, I guess, a little bit more interesting to take a look at the things kind of closer to real world. So for that purpose, I put together still primitive app, but it's kind of closer to the real life. And you can call this app something like a car manufacturing company, and the company has 2 departments. It's production department and its accounting department. Here we have in the production and accounting are 2 big components this app consists of. And in the production part, we have the queue of orders, and we can move orders, car batches, from orders to the production line, which consists of 3 steps. Then we move car batches from one step to another, and after the last step, we can sell them. The accounting calculates the data of the car batches that are in orders, of those that are in production, and of those that are sold. Also, accounting can order cars, and here we can clear sales. This is basically the data flow of this app, and also it has some visual addition, like here you can see that orders and each step in the production line, they have colors that can be transitioned from green to red, indicating of how loaded the step is. Also, there are these notification managers and small things like toggling off and on clear sales buttons. I have a few implementation of this app. The first one that you can see now, it's React Redux, and we will follow step by step how this basic React Redux application can be transitioned into using MobX, MVVM, view models, view controllers. So I'm going to review the code now. I obviously not gonna go line by line. I'll just point out the main parts that ultimately gonna be transitioned from React Redux to MVVM architecture. And let me open the code real quick. So before we dive into the code, a brief analysis of the data. Here in this app, we have some data that is, again, shared across the app between two components. And that data could be those orders that we have here on the left. The data for them is calculated here in the accounting component. We have cars that are in production line. They're entered here, and the data for them calculated here on the right. And also after the last step, we sell our cars. And on the right, we have the data for that is calculated for the cars that are sold. So I would say that those cars, that are in orders, in production, and that are sold, we can store as arrays in the Redux store. And here in the reducer, that's exactly what we have. We have 3 arrays that define our cars. Also, we need some actions that would allow us to move cars from orders to the production line, later sell them to order cars and to clear sales. So all those actions here. And now I'm going to review production line component, and I will review only this one in details just to save some time. Here in production line, we have orders, and we have the cars that were added into the production line, but also the production line has these 3 steps. And it probably would really make sense to store cars for each step in its own array. So 1 array for chassis assembly, 1 array for body assembly, 1 array for painting. Again, those arrays are pretty local to this component, so it wouldn't make sense to place them in the store. So we'll just define them as a regular React state with used state hook. And here is the implementation of the component. We want cars that are in orders, and those are stored in the Redux store. So we have to use selector here. But those 3 arrays for each step, they're defined with use state hook. We need 4 handlers here to move cars from one column to another. And for the first one and for the last one, we need to dispatch some actions, because here we change data in the Redux store. But the rest of them, we simply change data, those arrays for steps, and we're good with using setters that comes from use state only. So this is what's regarding the data flow. And here we also have those visual base and whistles like notification messages. And this is the logic that allows us to give colors to to the headers here. And pretty straightforward JSX. So this is the implementation, pretty basic implementation in React Redux. So now let's move to the first step of the transition to the MobX MVVM, and let's try to replace Redux store with MobX store. So here is example with React MobX store without MVVM, and clearly no any changes in the browser. The app works in the same way. There are, however, differences in the code, and I'll open it here in a second. So as I said, the goal here is to transition Redux store to MobX. So we take the arrays from the reducers and we convert them into MobX observables. Then we don't need separate actions anymore. Our actions are gonna be just methods on car store class, and those methods are going to mutate the observables we have here. So this is basically it. This is the entire store. And the production line component has now some changes as well, since the store is a different one. We don't have use selectors and we don't have to dispatch anymore. The actions as well as values we're using for rendering here, they come from the car store, which is available after injection. And again, no any dispatching. Here we had to dispatch. In the new implementation, we simply run the function. JSX, not really any changes. Everything looks the same way. So that is that. Now let's try to move to the next step and try to introduce view models to this app. And it's done in this example, and again, no any changes in the browser, but some new stuff in the code. This store here, the global car store for the app, MobX store is going to be the same. So the change that we'll see will be applicable for production line components. So to this one, right? So here, for each step in the production line, we had this React state defined. And now with the view model, we can convert that state into MobX observables. The handlers here now can be converted into MobX actions, and we don't need to use any setters. We don't need to use immutability because, again, MobX allows us to mutate things. In the constructor, again, we need to have an access to the global store in order to use data from there. So it comes into the constructor here. The part that allows us to generate colors for all those headers. Now the colors are converted into computed values. In the Redux implementation, React Redux in the implementation with regular React state, the calculation looked like that. Now those are computed values because they are calculated based on the observables that we have here in the global store. Now, if we take a look at the component itself, Really, that's how it looked like. All the state and logic is defined here. Now it's stateless and it's logicless, and everything comes from the view model. All the handlers we want to use and all the data we want to use for rendering is there. So for a lot of cases, that might be it, and we can get away with using a view model like that. There is, however, one more step that we can take. So if we do some analysis of this app or basically any other React app, we kind of have two type of data and maybe two types of logic. We have kind of data-centric logic, and when we move models from one step to another, when we order them, when we clear sales, it's kind of all data manipulation. But also we have those like visual things, coloring headers and displaying notification managers messages, toggling this button off and on. It's more like that visual centric logic. So I would say, what if we try in the view models to keep only this data centric logic, and visual centric logic we will move to the view controller, and the view controller, it's still going to use data and methods from the view model and simply to add on those visual things on top of it. And it's done here. And again, no any changes in the browser. Let's take a look at the code. And again, the change applies only to the production line component. And let's try to identify the logic here that would be more of a data-centric. And the observables, well, pretty data-centric since those are data. In the actions here, we mostly manipulate data by moving the models from one array to another, but also we have those notification manager calls, and those are pretty visual centric. This logic that allows us to color the headers here looks like really something that is visual. So we'll move that to the view controller as well. Once we get rid of all the visual-based logic, this is the view model we end up with. And here is the view controller. So view controller brings in the view model here. And I preserve the name of the actions, for example. I keep it exactly the same as in the previous implementation, because those we're going to use ultimately in the JSX, in the component. And those, as you can notice, they call actions from the view model, but they add notification manager calls to show the notification messages. And the part that gives colors to each step header, it was brought in without any changes. And if we take a look at the component now, previously we had everything come from the view model. Now all the values and all the handlers, they come from the view controller, and the view model we still needed, and it passed it passed to the component. It passed to the component from the outside. So we potentially could have instantiate we could have instantiated the view model inside of the component. However, the passing it from outside could be really useful. For example, for the cases where you have two components or even more components, and visually theirs are the same layout, they generate the same visual effects, but they can manipulate data in a different way. And the quick example, the last example for that is here. So in our manufacturing company, there might be two different accounting departments, and they might calculate data in slightly different way. Like here, one is Canadian dollars, another one is American dollars, and some filtering is done in a different way as well. But if we take a look at the code of this last example, so here in app.js, the entry point, we're using the same components to generate those two parts, and the view controllers would be the same. View models, however, are different, and you can see that they are indeed different. So just some difference in differential, some difference in filtering, but really, since that data, that difference is specific to data, we're able to contain it within a view model and reuse components and view controllers. Another thing that can be done with this approach, component, view model, and view controller, is let's say you want to build two apps. One would be React Native, another one would be React Web, and you can reuse your view models for both of apps. And clearly, for React Web, you have its own component and its own view controller, and for React Native, its own component of view controller, but again, the same view models. And even more than that, potentially, you can reuse the same view model and to use one with React and use another one with Angular, since MobX should work with both of those frameworks. The thing to be aware of, that really this you have to be careful with this approach, since it generates more code and it increases the API surface of your app. So really, sometimes it would be better to avoid using view controllers, and you can contain that logic inside of your component potentially, which I don't like that approach. But you can also include it into the view model. But anyways, if you decide to use both view models and view controllers, just make sure that all the members of your team are on the same page. And to wrap everything up, here is this brief schema of the implementation of MVVM. And if you think of view controllers, you can call it MVVM VC. So models in our store, they update view models, and then view model updates stuff in the component and in the view controller. And here you can see that view and view controller, they're in the same bubble, and that's because they really coupled together and they always go together. And you, in the best case scenario, have one single view controller per single component. That's it. If you have any questions, I can try to answer.
That was terrific, Andrei. I love the examples that you had. I love how you built things up step by step, and that was fantastic. If anyone has any questions, you can drop them in the chat, or if you want to speak up, you can go for that as well. Speaking of chat, while people are thinking of questions, I will say there's like somebody posted that they're looking for an internship. And if anyone else is looking for something, you can throw something there, and a link to the conference and the code were also thrown in the Zoom chat.
I had a question for Andrei. So I have not worked with MVVM, I guess, structures very much. And so I'm curious to know your background with them, if that's just a kind of a structure that you, or a mental framework that you prefer to work with. And like, have you done this? Have you created production applications with MVVM? And I assume that maybe you've also gone the kind of the typical React Redux route as well. I'm just curious to know a little bit more about the trade-offs and why you might prefer one over the other. I know you kind of touched on that at the end, but if you could elaborate on that.
Yes, I understand your question. I'm trying to see how I stop sharing.
Oh, I see.
Okay, stop share. Okay, I see.
There you go.
So yeah, answering your questions. I've done. So I probably should have brought that up and mentioned that during the presentation. So you can do MVVM approach with the Redux, and basically with any state management and potentially with any framework. I personally, I have this React Native project, which is kind of my pet project, but this is MVVM, but it's functional MVVM with React Redux. At my work in production, we use MobX MVVM. And it's clearly, it's OOP approach. It's not functional, except of maybe components. But in this approach, we really treat components more like the markup. Because they logicless and they stateless, and maximum that you see, maximum that you can see in the components are just lifecycle hooks, maybe. And the reason that why at my curious job, at my with the current project we have. At our company, the reason why we stick with MobX MVVM is because we have a lot of developers who transitioned from development of desktop C# applications into development of React, and we want to keep people in OOP world, and that's why specifically MobX was chosen.
So would it be fair to say that you guys appreciate the separation of concerns and having, like you were saying earlier, with the component being really specific to just the view itself and the rendering of it, correct?
So I do. So to be honest, we have a couple of projects to build using MVVM and MobX at our company, and we have people who stick to different views. So some people support the opinion that using view controllers is generating instances that are not really necessary. Other people stick to the opinion that separation of concerns is really important. I'm more on the side of this second opinion, but I guess the truth, as always, somewhere in between. Yeah.
Thank you.
Awesome. Anything else? Well, thank you, Andrei. We'll give it up one more time. Really appreciate that. That was terrific.
Sure, my pleasure. And yeah, all this code that I have there that I had the chance to demonstrate, there is like other part that wasn't demonstrated. I think we can attach a link to the GitHub repo, to the meetup page.
That would be
That's
awesome.
okay.
I was going to ask. I'm going to ask for that. Thank you.
Yep. Okay. I'll send it to Sam later.
Sweet.
Thank you, guys.
Thank you. All right, Sam, you get to throw up a quick intermediate?
Yeah. Do we want to have some time for a quick bio break or no? Either way works.
We'll talk for 2 minutes. If you need to run for 2 minutes, go for 2 minutes. do a quick chat.
Off, I guess, and
I'll jump ahead a little bit. We're always looking for speakers. I think we have one speaker next month that's been waiting in the wings for a bit, and really excited to have them announced soon. But we're always looking for new speakers. You do not have to be an experienced speaker. You don't need to have such amazing examples as the previous speaker. It can be a short talk as well as a long talk. So we like the idea of having one shorter talk and one longer talk. Usually we end up with 2 longer talks that aren't too long, which is great. But whatever you're interested in, whether you've spoken before or not, we're happy to mentor anyone that needs any support, help you even work on a topic, figure out what you're interested in or want to teach and what would fit with this meetup. So we're always looking for new speakers. Trying to think if there's anything else, but I will start to introduce the next speaker. So I was excited to see a talk on Microfrontends come up. I don't know if everyone knows what a microfrontend is. I'm afraid to define it for myself because maybe Sean will have a slightly different definition because it's still getting some traction, I think. Though I've been working with microfrontends of my own perception for some number of years now, and I'm excited to see what it looks like for Sean Michael. Sean?
Yeah, can you hear me?
Yes.
Great.
All right, let me share my screen here.
Awesome.
Give me 1 second. Zoom is asking for permission from my
Which is good.
Oh no, it's telling me that I have to quit to share my screen. Okay, I'll be right back. Sorry.
Cool. No, just go for it.
No sweat.
This is good. Everyone who needed a break is like, I'm gonna not be rushed now. Yeah, I appreciate that a couple more people posted that they're looking for opportunities. That is easier to do with, we used to do that in person, but it was kind of hard to, it just dragged things out a bit and a lot of people would be looking sometimes. So I think that with Zoom chat, we're going to add that to the slide, back into the slide deck. So next month we'll prompt for it so people can share who they are. Maybe we'll throw a slide in to ask people to throw in intros if they're new to Meetup too, new to the Meetup, to say, hey, here's who I am. I work at such and such up from somewhere. Because and after this talk, by the way, we'll do a little bit of informal chat and just banter and get to know each other a little bit more too. All right, Sean,
All right.
ready?
Yeah, I'm ready.
Take it away.
Well, I'm actually really glad, Will, that you mentioned that you have been working on micro front ends because it's something that I don't see too much of in the wild on the internet right now, as far as paved pathways of actually implementing these micro front ends. It's mostly a lot of people either hating on them or loving them. So I kind of wanted to give a talk today that kind of toes the middle ground and talks about the advantages and disadvantages. But basically, I've been spending the last 3 or 4 months helping one of my clients transition from a more traditional front-end architecture with a product suite of like 5 or 6 React apps to a micro front-end architecture that uses micro front-ends across those various apps. I wanted to share my experiences so far and hopefully shed some light on the pattern and when you may or may not want to use this pattern in the wild. So there's one caveat. I say micro frontends in the wild, but our application right now is in beta and we have very few users outside of the actual developers and internal people in the company at the moment. So I'm not going to be able to give you real stats on performance and stuff like that just yet, but maybe in a few months I can give another talk with the nitty-gritty details of this. So let me just start this off with the de facto introduction here. I am Sean Michael. I started a company called Integral Stack in January of this year. And it's basically just myself right now. I have over 8 years of web development experience, including front-end, back-end, engineering management, leadership. And I started the company to try to help other companies solve difficult tech problems and build custom software across the entire stack, hence the name. And I started the company right before COVID hit, and I had all these grand plans of doing networking, working from a co-working space, meeting all these people, and that didn't really happen. So any developers out there, if you want to chat development, please reach out on Twitter. You can reach out on LinkedIn. I'm always looking for other developers to collaborate with on future projects, so just hit me up. So I split this talk into 2 sections. The first section is going to be the fundamentals of micro frontends, and then some more details on how we actually implemented our micro frontends at my clients, at my client. So for those of you who aren't familiar with micro frontends, this section is going to be important to understand the context. And the next section will get into the details. So just be a little patient if you already have an idea of how all of this works. So let's start off with a good quote. Good front-end development is hard. Scaling front-end development so that many teams can work simultaneously on a large and complex product is even harder. And you will definitely run into this exact situation when you work at companies that have, you know, 10s, 20s, 30s, 40s, 50s, 60s of developers working on a product, and you have to figure out how to coordinate and work on this complex product together. And micro frontends is just an architectural approach to try to solve that issue. It's not a framework. It's not a tech. It's not like any sort of NPM package that you can pull in. It's just an architectural, I don't know, standard that you can use to try to solve that issue. And then I just added here that that little quote that I just said, and I have the person shrugging because I thought I pulled that quote from somewhere. I had it written down in my notebook and went back and couldn't find out who said it. So that might be my quote. But we have here at the bottom some logos of different companies that have implemented micro frontends that you may have heard of. Spotify, The Zone, Skyscanner, OpenTable, IKEA. I know that Spotify is using an implementation with iframes, but this is only in their desktop application. And I know that's cringy, but it actually works for them inside of the desktop application. So they've been doing that for a few years now. DAZN is a company that you should follow if you're interested in micro frontends. Their lead, Luca Mezzalira, is at the forefront of the micro frontend architecture discussions, and he has a lot of good stuff to say about them. And then I'll just note OpenTable. They have this open components framework that they created that basically hosts and serves up all of your components at runtime and has kind of serverless functions that are able to provide and orchestrate a front end at runtime on the fly. So that's an interesting project to check out as well. So what is a micro front end? We could start with talking about microservices on the back end. And I'm sure a lot of you have heard of microservices on the back end. They were created to combat the problems with monolith architectures, such as complexity, high coupling between areas of an app, leading to unintended side effects. So you might go in and you see this monolith here, and you might change something in one browse sector, or you might change something here, and it might affect browse and support when you only want to make a change in browse. And as your app starts to grow in complexity, you'll see those unintended side effects start to pop their head up. And then it also solves issues with team scaling. Communication and coordination overhead tends to increase when there's more devs on a project. And anybody who's worked on a team that scales above 12 people or so could probably attest to that. And scaling on the front end is usually an organizational problem. Now talking about micro front ends, not microservices, but scaling on the front end typically is not like a performance scaling issue because you're usually just deploying static assets to a CDN, which you're probably going to pick up through, you know, CloudFront or some other CDN like that, and there's no real performance scaling issues there. It's more of a scaling of the team and organizational problem. So just to kind of give an overview, the idea behind micro frontends is to think about a website or web app as a composition of features which are owned by independent teams. Each of those teams has a distinct area of the business or mission, and it cares and specializes about that specific distinct business area. If you're into domain-driven design, that could be a subdomain within the business. And a team should be cross-functional and develop its features end-to-end from the database to the user interface. So if you look at this diagram here, when you take a monolith front end and move it into a micro front end architecture, you're affecting the organization of your front end teams or the teams in your organization. And you're moving them into specific business verticals or subdomains. So you can see here we have user personalization, search, browse, support, shopping cart, which would all potentially have their own micro front end and also own features from the database all the way to the user interface. So just to give you a visual of how that might look in a front end, I lifted this from microfrontends.org, and it basically is showing you a stitch out of what could be a micro front end and how that is broken up by team and by technology. So one of the beauties about micro front ends is you technically do not have to pick a specific technology to use or framework to use on the front end. It's framework agnostic. So you can see here that this team product is in charge of this cutout, which is the store item and image, this little carousel of images here. And then your team checkout is in charge of the basket and the buy. And Team Inspire is in charge of these related products in the related product area. And this allows each of those teams to build and run a separate front end themselves and use the technology that they desire for that front end. And all this seems pretty straightforward, right? Pretty harmless, I would think. But then you look at what the community is saying. So you have Dan Abramoff in 2019 saying, I don't understand micro front ends. And that kind of started off a whole barrage of micro front end hate on Twitter. So you can see here, Sean Larkin tweeting about how micro front ends only optimize for developers to the nth degree and throw away performance, UI. I think he meant to say UX, I don't know what AX is, consistency and predictable design out the door. This guy here is saying that let's take a hype solution and only make sense for 1/100th of the backend architecture. I don't agree with that, and apply that to the front end because we all want to have a shiny CV. So there's a lot of hate, and some of it's definitely justifiable because this is not a panacea. Micro front ends is not something that you're going to pick up and use for a small startup that's just looking to get an MVP out the door. So what are the benefits and challenges of micro front ends? So I've kind of gone through a few of these, but on the benefit side, it makes simple decoupled code bases based on those business verticals that I mentioned. It gives you enhanced composition. You can pull those together inside of your container application in any way that you want. All of your micro front ends will be independently deployable, which will allow you to deliver value continuously for the business. So your team is able to deploy their code on a regular basis without having to coordinate across teams. And it coincides with cross-functional autonomous teams and microservices, which I kind of was just mentioning. And it's technology agnostic. The challenges are very tough though. So you have shared code and dependencies to deal with. And anytime you're talking shared code and dependencies in micro front ends, it's a bottleneck. So coordinating upgrades is very difficult. Deduping dependencies is also very difficult when you're talking about shared dependencies. You also have to worry about maintaining performance because now you're pulling in multiple micro front ends that may have certain packages bundled with them. And so you don't want to be repeating the same NPM dependencies across multiple micro front ends and pulling in the same code multiple times. You also will be challenged with minimizing complexity because it adds quite a bit of complexity to your front end stack. Shared events and state are also difficult to manage, and keeping UX consistency is a difficult thing to manage as well. So one of the main areas where micro frontends shine is team composition and being able to set up cross-functional autonomous teams. If you work in a small company or a startup, your team structure might look something like these product 1 and 2 up above, where you have a product, you have a team backend and a team front end, and both of those teams take on stories, work separately, and build their code for the product, potentially together, and have to coordinate together. And then you might have product 2 and another front end and back end team. This might work if you have a small team. It's not my favorite approach because I definitely would rather, if I'm a manager on a team, I would rather encourage people who are cross-functional, full stack, maybe can do a little work in both areas and carry a feature from start to finish. But there's nothing wrong with this per se. When you start growing in size and your team starts, your app starts growing in complexity, you will probably want to start reaching out for a team structure that looks more like this, where you're broken out by business subdomains or verticals. And what this does, it allows you to build your backend and microservices. It allows your team to own a feature from start to finish. And it just is a lot clearer. And I believe the strongest form of communication happens in an individual team when they're working closely together with a very consistent shared context and specific purpose. And so that's kind of what the structure gives you. So what did that, if you use a structure like this where you're broken down by vertical, what does that look like in the real world? It probably looks something like this. And this is what I feel like a lot of larger teams have, or bigger teams have. You'll see your business verticals broken down, and you'll have a team for each business vertical. And each of those business verticals may own certain, oops, not sure what happened there. So each of these business verticals will own a few microservices on the back end that may all communicate together, and they relate to the vertical that they're in. And this is nice because you have cross-functional, stream-aligned teams around a subdomain. You'll probably have 5 to 10 people on each of the teams, or a 2-pizza team, as Amazon calls it. And it allows a team to implement an entire feature on their own. But the issue still is that you have this front-end monolith sitting in front of these teams, and all these teams are collaborating on the same front-end monolith. And you can only imagine that deployments become very difficult. And this whole ability to deliver value continuously starts to diminish as you introduce this bottleneck on the front end. So that's why you might start working in micro frontends. And you might not notice the difference between these two slides at first glance, but what we have up here is a single orchestration app that then pulls in micro frontends. And just to note, I'm going to use MFE in some of these slides as an abbreviation for micro frontend. But the setup here is that you have this orchestration layer or orchestration service that will pull together your micro frontends and orchestrate them into an app. Now what you have is you have a front end that can be deployed individually, just as all of the microservices that are owned by that vertical or that team vertical. And you're able to deploy and deliver value to the company at a very fast pace in this setup. So let's move on to how you implement all of this. I've kind of talked a little bit about why you might implement it, what it looks like. But I wanted to go into the details to try to make this talk a little bit unique and talk about the challenges that we've run into and patterns that we've decided to use in order to implement these micro front ends. So this is what our architecture looks like with my client. And we have 5 different teams, all corresponding to a different vertical, business vertical within the company. And we have a React container or router application, which pulls together all of the micro front ends. And you can imagine that your browser would make a request to this router container application. And on the fly, it pulls in the specific micro front ends that it needs and renders those to the page. Now, these micro front ends each have their own API service or edge tier microservice written in Node. And these services are just set up to basically pull together data from the middle tier microservices, which communicate directly with databases and data sources. All of these services run on Docker. I think the advent of Docker has made microservices really a thing that is attainable, because we can provision and set up environments really quick and on the fly in the cloud. And because we are able to do that, we can easily deploy microservices for React, for Node, for Go, for whatever language you might need in these different layers of services. And then the other component that we've set up in our architecture is the continuous deployment or platform layer. And basically what this is doing is every time that you make a change, merge into master, if you're working on the content micro front end, for example, you branch off a master. We use GitHub Flow, and when you merge back into master, that will trigger a UMD build of the content MFE, which then gets deployed to S3, which has CloudFront in front of it for a CDN. And so your application is deployed to the cloud or to the CDN as a UMD file, which then can get pulled in at runtime by the container or orchestration app. And so when a user visits the web page, it will pull together those UMD builds and load them into the page itself. So we kind of cut some corners, and I think it was a good idea. One of the benefits of micro front ends is that they give you total independence, right? We talked about how you can use different frameworks for your micro front ends. But you can see this tweet. I really like Corey House and a lot of the work that he does and tutorials that he puts out. And he says here that the micro front end pattern that has people concerned is total independence. And he said he's seen the pattern work when you soften it a bit with strategic collaboration between teams, and doing so mitigates the downsides. So basically he's saying if you can agree on a tech stack, your container or orchestrator handles all API calls, and share some dumb components, maybe in a component library or something like that, and have some shared CI/CD, it will be very helpful in the success of your micro front end pattern. And we've done quite a few of those things on the list. And I think that when you normalize on a tech stack, it definitely helps the transition across teams for developers. If they need to touch different parts of the code, they can easily go and work on that. Or if they switch teams, they'll know exactly what to do when they switch teams. It also simplifies your shared resources. So one of the things that we have internally at the company is a shared component, React component library. And if you really wanted to go framework agnostic, you could do a web component component library, and that would allow you to pull in web components wherever you need them. But we stuck to React across the board, and I think it makes the developer experience a lot easier internally in the company. And we also set up a unified CI/CD for this. So you'll see in a second, I'll show you how we use a mono repo, and the CI/CD lives right in there using the GitHub Actions. And I think this also simplifies orchestration. You don't have to worry about how you're going to pull in a bunch of different apps that are written in different frameworks. So we decided to put all of our micro front ends in a mono repo. And the reason being, it just gives better visibility into all of the micro front ends that are in existence, how people are writing their code, solving different problems across these different micro front ends. So you can see here, if you have a project set up, you could just create a folder for all of your micro front ends and add each of those directories in there. And each of these would be a separate Create React app in our case. And at the top level, what we're doing is using Yarn Workspaces. And Yarn Workspaces is not necessary, but it gives you a few niceties as far as like setting up dependencies that might need to, dev dependencies that might need to be shared across the entire, all of your micro front ends. We've set up prettier configuration at the top level. So every single micro front end is enforcing prettier, and no one can really get out of that configuration, which is good, I think. And you can see here that having this mono repo, we're also able to set up our GitHub Actions. And this would be the same if you're using any other CI/CD tool, like Circle CI or something like that, where you can add your YAML configuration of your CI and CD directly into the repo with the code. And that allows all these micro front ends to share the same exact CI/CD processes. So you make a change to content MFE, and you merge that into the master branch. Well, these workflows will see that there was a change made to content MFE, and will deploy a new UMD build asset out to S3. And that's basically how the mono repo helps us out. So I need to talk about orchestration strategies, because basically so far all I've been talking about is pulling everything together on the client at runtime. But there are many other orchestration strategies that other companies are using. I tend to see a lot more tutorials online about client-side orchestration, but that doesn't mean that it's better or worse. It just seems to be out there a little bit more. I think I prefer it because a lot of these other orchestration strategies require additional services to be set up. But this first one here in the diagram is basically displaying client-side orchestration. Your client would get sent from the origin all of your micro front ends that it needs, and it pulls them together on the client at runtime. There is also edge side includes, or I believe edge includes, which sounds like some sort of just architectural pattern, but it's really a standard. So this is a CDN thing, and a lot of CDNs support it. I believe it's XML that you can write to determine how to include different pieces of HTML into a page at the CDN level. I know that AWS Lambda Edge supports it, so you could write this in Lambda Edge if you needed to set stuff up through AWS. But basically what it does is it allows you to pull together and orchestrate your application at the CDN level and return that to the client instead of on the server. And then there's server-side includes, which is basically pulling together your application old school style on the server and delivering that to the client. A lot of big companies still use this. It feels old school because it's what we did back in the day, but I feel like it has its use cases for sure still. So what are your client-side orchestration options? There's only a few. One is iframes, which I'm going to stay away from. I don't care if someone tries to tell me otherwise. I just gives me a bad feeling just talking about it and trying to think about all of the edge cases that might pop up around communication across iframes and that sort of stuff. The other way is JavaScript bundles. And what you do with a bundle is you pull it in at runtime, like I've mentioned already. You can do that in many different ways. You could include it in a script tag, or what we're doing is we are pulling in the UMD bundle at runtime, just using Axios, just using an AJAX request, and pulling it in, asynchronously loading that into our React app as a component. So that is the third one, the third point here that I'm talking about. And it's been working very well. It allows us to lazy load micro frontends whenever we need them. So say you visit a page that only requires one micro frontend, we only pull that micro frontend in. If you're using script tags, you're most likely going to load everything all at once, and that could be a performance catastrophe if you do not need all of those micro frontends on the page that the user is visiting at that moment. And you could also use solutions that are out there like Single SPA, which I haven't checked out. It seems like a solid framework, and basically Single SPA is the container application that orchestrates your routes and your micro front ends. And it's, you can look at it on GitHub. There's quite a few stars on it. And they also allow for lazy loading, which is nice. And then one other thing that I've checked out recently that is a new technology, I believe it's still in beta right now, is Webpack 5 has a feature called Module Federation. And what this allows you to do, it allows you to share code between multiple applications. So you can set up one of your applications as a host, and then, or as a remote, and then you can set another one up as a host, and you can pull in JavaScript at runtime from the remote to the host and run it inside of there. And it's pretty neat. You should check it out. The reason that we're kind of shying away from it right now is it seems to require you to run all of these remotes separately, or at least run a remote somewhere. And we're trying to create as little AWS architecture as possible to complete our goals. So I just want to throw this in at the bottom here, just in case people haven't looked at UMD modules before. And I feel like JavaScript modules get talked about very little in detail in the JavaScript world. We just kind of know they exist. So I know a lot of good developers who might say, oh yeah, what is UMD? But it's basically, it's been around for a while, and it's a universal module definition. And it's basically what we reach for when we want to pull in a dependency via a script tag inside of our application. And so I wanted to show what the top of the file of a UMD file looks like, just because it's interesting. And you can run through this and you can see that it looks for exports and it looks for module. And if it can't find either of those, then it moves on to check if function exists, and it checks to see if AMD is there. So the first one is checking for common.js, then we're checking for AMD. And then this last one here, if it doesn't find either of those, then it falls back to global or self. And in the case of a browser, that would be the window object. So it basically, in the browser, looks for this global or this styled property on the window object. So this is actually from styled components from the top of their UMD build. And this is the way that you would be able to use their UMD build in the browser. And that's basically what we're doing with our UMD loader. We're pulling in components at runtime. They get placed on the window object, and we pull them off the window object and render them as a component on the page. So what sort of issues pop up when we're doing this sort of architecture? you can see here we have our container application, which is for us, we're using Razzle. I would have preferred to use Create React App, but some of the developers wanted to have server-side rendering available. So our container application's running. We need React DOM. We have Microfrontends that we have in a separate mono repo. And each of these Microfrontends requires React and React DOM. And when we go to build these, if we're just using the standard Webpack configuration that comes with Create React App, we are getting a bundle with React and React DOM, right? And we're getting the same React and React DOM loaded into our container application. Now, if you try to do this in real life and pull in one of these micro front ends and load it alongside your container application, it actually will not work because we'll be trying to create two instances of React and React DOM, and React will throw an error at that point. So what you need to do is you need to find a way to filter out or remove or externalize React and React DOM from here and from here, and have it shared some way between your container application and your micro front ends. So the way we're accomplishing this is we're just using UMD packages from CDN, from unpackage. You can just set up script tags in your HTML, and you can grab a hold of React and React DOM. And then once you're grabbing it from there, you should only have one instance being run inside of the container application and for the browse or for the MFEs, the micro front ends that we have here. So what does that look like? Well, pretty much all of your bundlers have this idea or this feature of externals. So this is from Webpack, but I'm pretty sure Rollup and Parcel also have externals. And what this is doing is it's telling Webpack, do not bundle React, React DOM, and shared components with the code that we're trying to bundle right now. Instead, when you run this production bundle, look for globals on the window object called React capital, React DOM, and the shared components capitalized, and then replace the areas where we use them with these import names inside of the application with those globals. And so you can see here, if we put our script tags inside of our HTML page, just our index.html, we are loading the UMD modules into the browser, which puts them on the window object. And then our build that we set up knows to look for them there on the window object globally instead of looking for them inside of the bundle itself. So the challenges with this is you're breaking some of the rules or some of the niceties of this micro front end and microservice architecture with these product verticals. And that's because you need to coordinate now across teams to maintain a list of shared dependencies. You also need to coordinate major version upgrades of those shared dependencies, because when those come around and there's breaking changes, you may need to upgrade your container and all of your micro front ends to be able to work with those breaking changes. And all of that brings me to the next point, which is you need to be very selective about choosing what sort of dependencies you're going to pull into your project. You should probably stay away from any unnecessary dependencies. If you don't need Lodash functions, don't bother. If you don't need, I don't know, some other package that is unnecessary, don't bother bringing it in if you don't need it. And the reason being is that this could potentially impact performance and add bottlenecks. You know, say you have 2 or 3 different React micro front ends that are pulling in the same React component. You're repeating that code in 3 different bundles that might get loaded into the user's browser, and you could see how that'd be a performance bottleneck. I would just recommend use HTTP2 for multiplexing these dependencies If you have a lot of these dependencies that are shared and you're pulling in through script tags, if you're using HTTP2, you should be able to multiplex them and load them in parallel instead of loading them one after another. And you may be sacrificing tree shaking by loading in these dependencies as UMD bundles. And the reason being is that when you get tree shaking, it's able to kind of go through all of the imports of your code and figure out what portions of a library you actually used and only pull those into the bundle, leave out the portions of the library that were unnecessary. With pulling in these UMD builds or UMD bundles of these third-party dependencies, we get the entire package. They don't know ahead of time what part of the package your app's going to use, so you're loading that entire package. One of the things that I want to look into, I just noted here, is import maps. It seemed like it may have some, might be able to help out with some of the overhead of pulling in these dependencies and managing dependency upgrades. So another challenge, shared state and events. So what do you do when you need to share some sort of state across multiple micro front ends? And what do you do when you need to communicate from one micro front end to another to say, hey, this event occurred? And my answer would be, don't do it if you don't have to. Stay away from shared state and events as much as possible. And if you can, use the browser URL. The URL is the best way to share state across the micro front ends. It's the simplest way. So you could see here, if you were you had a search micro front end and a browse micro front end with results from what you searched. When that search is made, browse can pull from the history state and be able to make a asynchronous call to get the results for wild. And wild can also maintain state from the query parameter that we have in this query string at the top. So leverage the browser URL as much as possible, but that's not always going to solve all of the needs that you have. So when you cannot use the history state or the history API, you might want to leverage something like event busing. Event busing is just an implementation of the pub/sub pattern where events are passed to a pipeline and subscribers listen to certain events in the pipeline and react to them. So it's nothing special. Usually these event busing libraries are pretty small and they usually leverage the window object to send messages around between micro front ends. So basically it's leveraging the browser's API or the client API in order to actually send messages and state. So like I said before, avoid sharing state if possible. And I'm going to bring this up a second time in our talks right now. One of the patterns that some of our developers are leveraging is the view model pattern on the API side. And so we're trying to leverage the API to direct and drive the UI itself. So a good example is in youtube.com. If you go to the user menu and click on it, they're not figuring out what to display in that menu on the front end. They're making an API call that then returns or sets up a view model for the front end that can display exactly what the user should see based on what their policy is and what sort of settings they have set up. So you can also leverage the API for some of that. And if you have to share state, you may be able to use React Context. Just be wary that you can only use, you cannot create two implementations of the same context. You need one implementation, so it would need to be externalized at that point. Or you could leverage native web storage like local or session storage. And another challenge, so end-to-end testing. This is another challenge you can imagine because we now have disparate applications that developers are contributing to. but we want to know that the entire integrated application works as expected. I tend to ascribe to Cascadia's testing trophy. I find it to be most useful as far as getting test coverage set up in the front end. So we're trying to write a lot of integration tests inside of our micro front ends and the container application. You know, they're cheap, so we leverage them as much as possible. Some unit tests in there as well. I wish we had TypeScript, but we're doing our best with ESLint and some static tooling that actually goes through our code and looks for code smells. And our end-to-end testing is probably the most difficult part of this puzzle. So what we're doing is we're setting up end-to-end tests with Nightwatch.js inside of our micro front ends for each of them. And we tag each of those micro front ends with the name of the micro front end itself. So when you go to deploy a new micro front end, we can run tests specifically on the tag of the deployment and make sure that the part of the deployment that you're running for the micro front end is the one that gets tested in our pre-prod environments. Now, we also want to run tests that test the integration of all those micro front ends as they get pulled together into the container. So what we're doing inside the container application is during our CD process, we're actually reaching out to our monorepo and downloading the end-to-end tests from there. And we're able to run those end-to-end tests as part of our container application deploys to make sure that we didn't break anything in the micro front ends when we deploy and make changes to the container application. CSS is another challenge, although this is a lot easier. Just do not use shared global styles. That's the one thing you need to watch out for. You can imagine that your styles would leak across multiple micro front ends. If you're using global styles, you could easily clash with another class that was coming from a micro front end and would never know. So you really want scope CSS. There's so many ways to do this. We're using styled components, but you could use CSS modules, just regular post CSS processing. Apparently now native CSS has, I don't think the browser support is there, but native CSS has CSS scoping in it, and web components allow you to scope for the shadow DOM. And I don't know what the support around that is either, but stick to scope CSS, you should be good. And once you start to see repeated design and dev patterns, you should start considering that for the shared component library if you have one set up for your organization. So just a note here, we're using theme providers to drive the themes across micro front ends from the container. And if you use style component theme provider, that provider needs to be externalized because there can only be one instantiated across the multiple applications. So should you use micro front ends? The question is, it's really up to you, but you probably do not need them in most cases. So first I would kind of challenge you to ask questions, hard questions about your application and your team that could kind of guide you on whether or not to use them. The first question is how many teams or engineers work on your front end code base simultaneously? If you told me that, you know, we've got one team of 10 or two teams of 6, I'd probably say the chances are you probably don't need micro front ends. The company I'm working with right now, I believe they probably have somewhere around 50 to 60 engineers working across multiple teams. And that's why this is actually something useful for their structure and their environment. Would your company benefit from autonomous vertically segmented teams with independent front-end deployments? So yeah, that kind of goes back to the product verticals that you might divide your teams up into if you have big teams. You want to also ask if your product suite would benefit from reuse of micro front ends across multiple apps. So if there's certain portions of your app that are repeated across other apps that you're building, that might be a good use case for micro front ends where you could pull in the same micro front end into multiple applications. And another question is, how big are your front end code bases? If you've relatively small code bases, you probably do not need this. So I just put some tooling and resources on here. I mentioned a lot of this stuff already in the talk. If you do investigate, follow Luca Mezzalira on Twitter. He's really good and he talks a lot about micro frontends. And that's it for my talk. Reach out to me if you want on LinkedIn or on Twitter. I'll always hit you back.
That was awesome. Thank you, Sean. I can say firsthand that I think 95% of your talking points I've personally experienced, and that was an excellent introduction to micro front ends and overview of so many considerations. I really enjoyed that. I might have some questions, but I wanted to see if anyone else does. You can jump in on Zoom or you could throw it in the chat. We've had a little bit of a side chat going as the talk has been going, which has been good.
Sean, I have a question. Here's Regina. How have you solved the versioning issue? Because couldn't it be possible that different micro front ends, let's take the assumption that you have multi-clients and each client uses a different version of a micro front end. How would you handle that?
I think the idea, I would avoid that. The idea is that the micro front ends are continuously deploying and you're always receiving the newest code. We have a custom canary setup that we've built with Optimizely just to check our micro front ends and push them out to segments and test them before fully pushing them out to the full audience. But yeah, I would stay away from versioning your micro front ends and pulling in different versions. If you have this need to have different variations and versions across different applications, it might not be the right use case.
Thank you.
I wonder about how has your experience been with changing the shared components across your application or making sure that there's not a breaking change across all the different use cases?
Yeah, so because the beauty of being in beta right now is that we haven't had to deal with every single issue, but I can say that the one thing that I've seen so far is that developers are relying on classes for testing every once in a while. And that has become an anti-pattern within the company. So always stay away from kind of using those classes because they might change classes and that might not be a major version bump in their shared component library. Major version bumps are where the issues come in. So we haven't kind of delved into solving that issue. We've talked about ideas of how we might go about it. Right now, the main externalized packages we have are the shared component library and React and React DOM and stuff like that. So my guess is that the only shared package that will pose issues is probably that React component library major upgrades. So what we'll have to do is probably coordinate releases across our container application as well as our mono repo of micro front ends in order to coordinate releases that go out around the same time.
And that shared code, do you manage it through, like you actually pull it in through like a GitHub branch, or are you using NPM like private repos, or?
Yeah, so these shared code that I'm talking about are all those UMD builds that get pulled in through the script tags at the top of the page. So in the case of, say we upgrade our shared component library, what we would need to do is push out new versions of our micro front end that update for the breaking changes and turn off our canary releases until our container application is ready to go. And once our container application deploys, switch on all of our canary releases. So we need to find a way to do that. I don't have an elegant solution off the top of my head right now.
Yeah, it sounds like a lot of moving parts. I had a question around, like, is there any sort of a migration strategy? Say you're a small to medium-sized team and you would like to kind of pursue an approach where you split a feature out, or maybe build a new feature that implements a micro front end. Is that something that you would even advise? I don't know if that makes sense, but could you incrementally do something like that in your existing app as the container?
Yeah, I think you could. I don't know. We're doing a full rewrite, which I think is perfect for it. I've heard of other presenters or other people in the space talking about using the microservice strangler pattern, which is just a way that people go about upgrading legacy code with microservices one piece at a time. So if you're able to implement your, change your app around a little bit so that it can handle being a container application and orchestrating micro front ends, you could technically start rebuilding portions of the app as micro front ends and do that incrementally until you have the full application set up. So I think the answer is yes. Yeah, I don't think it would be too crazy of a lift. But yeah, I mentioned this to my client, and they were very eager to hear feedback too. So if any of you have more questions after this, or just want to have a conversation about this stuff, I'd be happy to talk.
Thank you. I think I'm gonna need to hit you up on that, Sean.
Cool. Yeah. I definitely want to hear what other people are doing and steal good ideas.
Sounds great. With that, I think we'll bring this to a semi-close. I want to offer up an opportunity for people to chat over Zoom or in the chat itself. I wish I prompted for intros because there's a bunch of names I see here on the call that I don't know. Really happy that everyone stuck. This was a very strong turnout, staying very strong. I really appreciate all of you hanging out with us. Thank you, Sean. And thank you again, Andrei. Those were two terrific talks. Tonight was fantastic. So looking forward to sharing the recording later. Anything to add, Sam?
No, I just wanted to echo what you said. Those are two terrific talks. And I know Sean kind of plugged his consulting company there, and just wanted to mention, because he didn't mention it, but I had the pleasure of working with him at Salt, and I cannot vouch for his skills enough. So if you're looking for somebody to hire on a consulting basis, I definitely recommend Sean. As you can see from his talk, he's extremely capable.
Thank you.
That's all I've got. Thanks
Awesome.
for coming out, everybody.
Yeah.
And we can just, people want to stay on and chat, feel free to. I'm going to end the stream at the very least. And I did mention it in the chat that the whole event's recorded. So you can find it on our YouTube channel after the event if you ever want to reference either Andrei or Sean's talks. And same goes for any event we've had in the past, what, 2 or 3 years now at this point. So
Like 3 or 4 now. It's ending up